Last PPT class, we had started with fermentation media. Just a recap of what we have studied. I have already told you two important points. Please remember that fermentation media, the criteria for a fermentation media. Criteria means which is a good fermentation media. So those first 3 points you can see, that is what we have studied in the last class, PPT class. They are the properties of a good fermentation media, that it should allow maximum biomass growth, maximum product, maximum yield. It should be cheaply available. Media should be of good quality, available throughout the year, easy to prepare, easy to sterilize, that is manage, and easy to dispose after the fermentation. So all these 3 points I have clustered it together is what we have discussed in detail in the last class, that is criteria for a good media. And then I also told you how important is media in fermentation. I told you the design of a fermenter depends on media, and microbial behavior depends on media. Economics of the fermenter also depends on media. And and one more thing I want to tell you, what is media formulation. I have told you in the last class, media formulation means in the industry people will not use media. So for example, they are growing E. coli, means they will not refer any books, they will not prepare nutrient broth, they will not prepare any media available in books. For that E. coli strain, for example, what media is suitable, they will do experimentation, and that is called media formulation. Media formulation means create the media suitable for the organism which you are going to use in the industry. That creating a new media for your own organism is called media formulation. So what is media formulation is, find out how much of carbon is required, how much of nitrogen is required for your organism, how much of micronutrients, trace elements are required for your organism, how much of oxygen you have to give. Put together, the organism will grow, it will produce product. So we are going to start with media formulations. As I told you, it is not easy to quantify requirements properly. See, very difficult. You refer books for so many media, but preparing a perfect media for microorganism is very difficult. You have to do an extensive study. You have to give different amount of carbon, nitrogen, and you have to see in which condition organism grows properly. So it is something like a research work to find out proper media for microns. So as I told you, though you do put so much of hard work in the industry, people do it, it is not easy to quantify precise requirement. Precise means exactly this much of carbon, this many milligrams or grams of carbon should be given. Very difficult to do, but such work only people do in industry. They call it as media formulation. Very difficult work it is. So what has to be done here is micronutrients and trace elements are also very important. So just media is not basically carbon and nitrogen, though carbon and nitrogen are called macronutrients. Microbial growth depends more also on micronutrients. Micronutrients means something added in less quantity. So those nutrients and trace elements you have to be very careful, because even if you reduce little and or increase the micronutrient or trace elements, either it will support the growth of bacteria or it will support the product formation. Something will get affected if you increase or decrease micronutrients. So such experimentation is called media formulation, which is very important in the industry. See, some examples I have given you below. Some components always required in excess. Potassium, phosphorus always required in excess. Some components always should be added in limited quantities. Example, zinc and copper, always it should be added in limited quantity. And some nutrients, some microorganisms also require additional nutrients. You can see example, we call them as growth factors. See, some organisms may require vitamins separately, how to provide them. It may require some amino acids separately. It may require nucleotides separately. So those requirements also you have to find it out and prepare a media. That process is called media formulation. And finally, very important, last point, you just see elemental composition of microbes. Elemental composition of microbes means you should also find out, very important is, what is the cell made up of. See, what is cell made up of, that only it will require. See, a cell is made up of more amount of iron. then it may require iron more for growth. Like that, elemental composition of microbes means what is basically a cell made up of. So your cell, the cell what you are going to use in industry, its elemental composition you should know. Based on that only media can be formulated. Say I put a table. This is an example of elemental composition of cells. This knowledge is essential for preparing a media for microorganisms. You can see here, the first column is media components are given: carbon, hydrogen, nitrogen, phosphorus, sulfur, potassium, sodium, calcium, magnesium, chloride, iron. And in the next three columns you can see bacteria, yeast and fungi. So you can see bacteria, for example, if you take first compound carbon, you can see bacteria requires carbon in a range of 50 to 53. But yeast requires the same thing in a range of 40 to 50. So the requirement elemental composition of a cell varies. A bacterial cell is made up of 50% of carbon, while yeast is made up of 45% of carbon. Bacteria is made up of 7% of hydrogen, and similarly bacteria is made up of 12 to 15% of nitrogen. Here you can see a lot of difference. Yeast is made up of 7.5 to 11% of nitrogen. That means, what do you understand? For example, if I take nitrogen, you can see clearly that bacteria requires more nitrogen than yeast. That is the meaning of this, because bacterial cell has 12 to 15 parts of nitrogen, but yeast is having just 7.5 to 11. So clearly it shows that by knowing the elemental composition of cell will surely help you in preparing media for that particular microorganism. So next very important thing while preparing media is this particular concept called cellular yield coefficient. See, this heading may come for just 3 marks also. What is cellular yield coefficient? It is represented as Y, capital letter Y. Y is equal to, we can observe that Y is equal to quantity of cell dry matter produced divided by quantity of carbon substrate utilized. See, you just observe that the equation, quantity of cell dry matter, that means how much of biomass is formed, depends on, it is divided by amount of carbon utilized. That means directly cellular yield coefficient means how much of carbon is used by microorganism is equal to that much of biomass, that much of growth of microorganisms. So just to make you understand this equation, below one example I have given. Just observe the example. Y is equal to, Y means cellular yield coefficient is equal to 0.5. What does it mean? I will tell you. See, Y is equal to 0.5 is a value. 0.5 is called as cellular yield coefficient in this example. Let us see what it is. Below you see, that is 0.5 means 0.5 grams of cells to grow just listen to me, to grow 0.5 grams of cell, you require 1 gram of glucose. That is, 1 gram of glucose supports 0.5 grams of cell growth. That is the meaning. That is what is Y. Y is equal to 0.5 means 1 gram of glucose can support 0.5 grams of cell growth. So the question, next point, if you see, therefore, what is your requirement in the industry? Suppose if you are requiring 30 grams of yield, you are requiring 30 grams of cell growth. Let us assume your yield is cell growth. You are expecting 30 grams per liter. 1 liter, every 1 liter in fermentation media, you are expecting 30 grams of yield. So last point, you see the calculation is, so if you require 30 grams, you divide 30 grams, that is requirement cell dry mass required is 30 divided by substrate utilized is, that is 0.5, that is 30 divided by 0.5 is 60 grams. So 60 grams of what you call it as glucose, if you supply, you will get 30 grams of yield. So that is what is cellular yield coefficient. So it helps us to find out the requirement. It helps us to it helps us to make media formulation, that is to formulate a media for microorganisms. So this is just a table. In this table you can just see that substrate is there. Example, methane, alkane, methanol, ethanol, acetate, malate, glucose, all these are different types of substrates. And in the next column you can see cellular yield coefficient. Cellular yield coefficient is designated as grams of biomass, dry weight of biomass per gram of substrate. That is the meaning. So how much biomass you are getting per gram of substrate. So that is what is given in the column below. Methane, you can see methane supports, that means every gram of methane you are giving in media, you are getting 0.62 grams of biomass, that is cell. That much of cell grows per gram of methane. So you can see which is having high cellular yield coefficient. You can see alkanes. Why alkane 1.03? The value is highest. Why? Because alkane is a fatty acid. Fatty acid means it has more carbon than glucose. That is why the yield will be more there. Cellular yield will be more. So you can see 0.34 is lowest, that is acetate. You know, acetate is one of the smallest. It is 1/3 the size of glucose. So naturally it will give very less yield, 0.34. Glucose, you can see 0.51. That means 0.5 grams of biomass you will get per gram of glucose. So students, what do you understand here is that media formulation, to do media formulation we should have the knowledge of cellular yield coefficient. So the next part of the slide we will see in the next PPT, as we are reaching the time limits.